Okay, so graphing tangent and cotangent. So just like when we did sine and cosecant, cosine and secant, tangent and cotangent, they are reciprocal functions. Now they have a lot of similarities to what we've already been doing, but they do have one kind of main difference. And that main difference is when we're figuring the period, with all of our other functions, the period's always been 2 pi over b. With our tangent and our cotangent, it is just simply pi over b. Okay, so instead of it being a period of 2 pi divided by the b value, it's just simply pi divided by the b value. The example here that we're going to use for this first one, we're going to do y equals tangent, and we're just going to do 3x. We'll do a real basic one here for this first one. The other difference is tangent and cotangent does not have an amplitude because we don't really have a height within our curves for the tangent cotangent. So what we do have, instead of an amplitude, we have a stretch. Okay, so that value that we were finding for the amplitude before is now basically going to be considered our stretch. So let's just go through this process. So the stretch, again, is the a value that's in front. So we'd say in this case, the stretch would just simply be 1. The period, again, instead of doing 2 pi, we're going to do pi divided by 3. So it's just going to make the period pi thirds. The interval, we're still going to divide the period by 4. So the interval, if I do pi thirds and divide that by 4, that's going to give me pi twelfths. Again, our phase shift and vertical shift, they're the same. In this case, we have none. Vertical shift, none. And eventually, we will also find the domain and the range after we graph it. Now, there is a difference between tangent and cotangent, a couple main differences. With tangent, we are gonna start, it kind of splits the y-axis. So if we don't have a shift, I think the best thing to do is we're just going to put 2 marks on each side of the y-axis. If we know our interval here is pi 12, so we go pi 12ths, 2 pi 12ths, which would be pi 6. And you got negative pi 12ths and negative pi 6. Now, as I said, the tangent, it kind of splits the y-axis. So we're going to start at the origin. The regular tangent curve, so I start there. These are going to be my asymptotes here, the 2 lines that I just marked. Our stretch, the interval between the asymptote and where I'm starting is going to go up to that stretch of 1. And then at the negative 1, I'm going to go down to negative 1. So my general tangent curve goes up and to the right, approaching the asymptote, and down and to the left, approaching the asymptote there. So again, if I were to make four more lines here, again, I would have a repeating pattern here, and there would be another asymptote going here. Goes up and to the right, down and to the left. And again, it would continue to repeat as we go there. So tangent, again, it splits the y-axis. Now with the cotangent, which we're going to look at a cotangent here in just a minute, the cotangent actually starts with an asymptote at the y-axis. So it's actually kind of shifted over to the right. Before we look at the cotangent, let's go ahead and identify here our domain and our range. Pretty similar to what we just did with the other asymptote problems with our cosecant. We're going to say for all elements x, such that x is an element of the real numbers, except when x does not equal. So notice in this one, the furthest one to the left here would be my negative pi sixth. The distance from this asymptote to this asymptote is my period length, so that is pi thirds. Then I'm going to put k after it, where k is an element of all the integers. The range on our tangent curves is pretty similar. Well, it's a little bit easier to identify because we don't have to do a union, because it's going to be negative infinity all the way to positive infinity. Okay, so let's look at a cotangent now. So example 2, I'm going to say y equals 2 cotangent of 2, and then let's go x plus pi in the parentheses. So again, thinking about tangent and cotangent being reciprocal functions, when we're looking at our graph of a cotangent, the cotangent is going to go up and to the left and down and to the right when we're plotting it. And the other difference is the cotangent asymptotes are going to start at the y-axis. So let's just list our values here. So our stretch, in this case, the stretch is 2. The period, we're going to take pi divided by b. Well, b in this case is 2, so the period is going to be pi over 2. Our interval, again, we're going to divide by 4, so that's going to make my interval pi 8. My phase shift, if I set what's equal to, or set the parentheses equal to 0, my phase shift is going to be negative pi. And we do not have a vertical shift here. No value underneath. Okay, so if we go to our graph, And as I said, with the cotangent, again, it's going to be shifted to where we're kind of shifted to the right. Now, this one does have a phase shift of negative pi. So I'm just going to put, let's go out here to negative pi, let's say. Again, if we split that in half, we know that we're going to be at negative pi halves. We know that that's our period. And then just do the same thing on this other side. Pi halves and pi. So at negative pi, that I'm going to immediately have an asymptote. We know that our period length is pi halves. So again, I'm going to have an asymptote there, asymptote at the y-axis. Again, if I split this, we know that the interval is pi eighths. So this would be halfway between negative pi halves and pi would be, what, negative 3 pi fourths. And then there would be our interval there. So middle point, we know in this one the stretch is 2, so I'm going to go up 2 for my next point. So up to here and down to here. So again, going up and to the left, down and to the right. And again, if I mark a half, same kind of process here in between. Up and to the left, down and to the right. And there would be my cotangent curve. Now, if we identify the domain on this one, and for all x, such that x is an element of the real numbers, we'd say x cannot equal. On this one, I'm just going to start at negative pi plus, we know the period length from negative pi to the next asymptote is pi halves. K, where k is an element of all the integers. And then our range here is from negative infinity to positive infinity. So again, just kind of talking about some of the differences here between the tangent and the cotangent. Cotangent is shifted over, so the y-axis is kind of our starting point of our asymptotes. Also goes up and to the left, whereas the tangent goes up and to the right. Review again, if it would have been a negative cotangent in front, then again it would look like your tangent curve because it's going to reflect and go up and to the right, down and to the left.